Whole numbers are numbers in the sequence 0, 1, 2, 3, 4, 5, 6, and so on. So the smallest whole number is 0, and you can keep finding larger whole numbers by adding 1 over and over again. So note that negative numbers are technically not whole numbers. Okay, so which of the numbers down here are whole numbers? Right, -4 is not a whole number because it's negative. 0 is the smallest whole number, 12.73 is not a whole number, and 18 is a whole number. By the way, whole numbers are also sometimes called the natural numbers. Okay, so next, which of the following sentences are true? If you add two whole numbers together, like 3 and 7, do you always get a whole number? What if you subtract whole numbers, like 3 minus 7? Right, 3 plus 7 is 10, another whole number. Adding whole numbers always gives you a whole number, but that doesn't work for subtraction. If you're subtracting a bigger number from a smaller one, like 3 minus 7, you'll get a negative number, which is not a whole number. Okay, so these are the whole numbers. If we go ahead and include the negative numbers in this list, that is, the numbers we can get if we keep subtracting 1, we now have a set of numbers known as the integers. By the way, another name for the whole numbers, this group of integers over here, is the non-negative integers, because they're all the integers that are not negative. Okay, so here are the numbers from an earlier question. Which of these are integers? Exactly, 12.73 is the only number here that's not an integer. As with whole numbers, adding two integers together always gives you an integer. And with integers, the same goes for subtraction. Subtracting one integer from another always gives you an integer. Okay, so then which of the following sentences are also true? If you multiply two integers together, like 5 and 2, do you always get an integer? What if you divide integers, like 5 divided by 2? Right, 5 times 2 is 10, another integer. Multiplying integers always gives you an integer, but that doesn't always work for division. 5 divided by 2 is 2.5, which is not an integer. To get started, can you identify which of these numbers here are integers? Right, of these numbers, 22.3 is the only one that's not an integer. Now, rational numbers are numbers that can be written as a quotient of integers, meaning they can be written as an integer divided by another integer. Let's see some examples. 3/4, that's a rational number. It's 3, an integer, divided by 4, another integer. 50/70 is another example. Now, as a fraction, it's not simplified. It's the same as 5/7. But both 50 and 70 are integers, so this is a perfectly fine rational number. 19/6 is another example. Here, the numerator is greater than the denominator, but they're both integers, so it's a rational number. Rationals can also be negative, like -4/15. -4 is an integer, as is 15. 0 over 2 is yet another rational. But what about 2 over 0? Now remember that you can't divide by 0. The result is undefined. So this is not a rational number, because it's not even a number. Alright, so see if you can identify which of these expressions down here are rational numbers. Exactly, you can't divide by 0, so 0 over 0 is undefined. These other numbers are all rationals. Okay, so what about decimals? Is 0.4 a rational number? It sure is, because 0.4 is the same thing as 2/5, and that's an integer divided by another integer. How about 3.25? Yep, that's also a rational number because it's the same as 13 divided by 4. Try another example. If you have the decimal 0.333333 and so on, where the threes keep going after the decimal place, this turns out to be a rational number. To prove it to yourself, can you write this decimal as a fraction with an integer numerator and denominator? Excellent! 0.3333 and so on is the same thing as 1/3, so it's definitely a rational number. Now try an example that's a fraction but with decimals in the numerator and denominator, like 2.5 over 1.5. This is yet another rational number. Can you rewrite it as a fraction with an integer numerator and denominator? Right, so there are many correct answers here. You can write this as 25/15, and in simplest form, it's 5/3. So yes, 2.5 over 1.5 is yet another rational number. So then which of the following statements are true? If you add two rationals together, do you always get a rational? What if you subtract two rationals, or multiply them, or divide them, as long as you're not dividing by 0? Exactly right. These are all true. You can convince yourself by adding, subtracting, multiplying, or dividing fractions. As long as you're not dividing by 0, your result will always be another fraction. Okay, so that's an introduction to rational numbers. Seems like every number is a rational number, right? Well, not so fast. In a later lesson, you'll learn about what are called irrational numbers, which are all the numbers that cannot be written as a quotient of integers. Irrational numbers are out there. Maybe you already know about one or two of them.